Okay, today's lesson is going to be a continuation of what we did last week when we kind of explored the x and y intercepts. We're going to look at graphing lines when they are in what we call standard form. So if you're in standard form, we call this ax plus by equals c. Now these a, b's, and c's will be numbers. In the first example that we're going to do in a moment, the equation looks like this. Negative 8x plus 12y equals 24. So if you notice, your x and y are on one side of the equal sign, and then on the other side you just have a number. So that's very different than y equals mx plus b. Y equals mx plus b looks something like that, where y is all by itself. This is called standard form. So I'm just going to put a couple examples in here. Actually, I'm going to rewrite this one. I should have just used that one over there. You could also have something like this. Maybe just a plain, not a plain x and a y, but an x and a y with a 1 or a negative 1 as coefficients. So add those couple examples to your notes. Now, when we're in standard form, there's different strategies we can use for graphing. So in your notes, we kind of split it up into method 1 and method 2. The first method, which we're calling method 1, says this is a literal equation. Remember back in chapter 1 when we took equations and it said solve the literal equation for y. And I said, well, that's the kind of like just a rearrangement. We want to rearrange the equation so we have y all by itself on one side of the equal sign. The reason we did that in chapter 1 was to get you ready for chapter 3. If you notice, slope-intercept form has y all by itself on one side of the equal sign. So that's the first method when you have an equation in standard form, is to do some algebra to get it in slope-intercept form. So we want to get the y by itself. The negative 8x is added, so we want to undo addition or subtraction first. We want that whole 8x to hop over the equal sign. Negative 8x and positive 8x make a 0. So I'm left with 12y equals, I'm going to write that 8x first because I want it to look mx plus b-ish. We're used to seeing the slope first, then the x, then the y-intercept. So I recommend you do the same. Write that 8x first. Okay, now to get y by itself, I need to undo that multiplication. I need to divide every part of the equation by 12. 3 parts. 12 divided by 12 is 1, so I have 1y. There we go, y by itself. 8 over 12 is a fraction that can be simplified. Either use your calculator or think 4 goes into 8 2 times. 4 goes into 12 3 times. So I'm dividing top and bottom by 4. So we want a simplified fraction. We do not want a decimal because this 2 over, hang on, let me erase that. 2 over 3 is our slope. So that's going to be our rise and our run. So we do not want a decimal there. Over here we have 24 divided by 12, which is 2. So our y-intercept is 2, which is the coordinate point 0, 2. So I'm going to graph my y-intercept first on the y-axis at 2. And then from that point, I'm going to rise 2 and run 3. This is a positive slope, so it should look puff, puff positive when I'm done. So from this point, I'm going to go up 2 and over 1, 2, 3 and put another point. If I want some on the other side, do the opposite. Go down 2 and to the left 3. Okay, draw a nice straight line with arrows. So method 1 says take your standard form and do some algebra to get it into slope-intercept form. So this equation right here, y equals 2/3 x plus 2 is slope-intercept form. Now, the other method is using the x and y intercepts. So we did a little bit with these on Friday. So if you don't like the solving for x, oftentimes when you have standard form, you can find the x and y intercept. So let's just remind ourselves, when we're finding an x-intercept, that's going to be a coordinate point that has an x, but the y is 0. The y-intercept is going to be a coordinate point that has a y, but the x is 0. So if you want to find x and y intercepts, you let the other part of the coordinate point equal 0. So I'm going to start by saying, let's let x equal 0. So in this equation, I'm going to replace the x with a 0. So I'm going to throw out the x and put a 0 in there. So if I copy that equation, but where the x is, I'm going to throw that out and put a y in there. This is what I'm going to have. So I recommend you divide your paper in half like this. And let's do two equations, one where we let x equal 0. That's the one I'm doing right now. So then this would look like, instead of negative 8x, it'll be negative 8 times 0. Now this works out really nice because 0 times 8 is just 0. And then I'm left with basically 0 plus 12y equals 24, but I can forget that 0 because adding 0 doesn't do anything. And then I want to solve for y, so I'm going to divide both sides by 12, and I get y equals 2. So the coordinate point here, when x is 0, y is 2. That is the y-intercept. It has a y value, but the x is 0. So let's plot this point. I'm going to start at the origin. I'm not going to walk right or left. I'm going to climb to 2. So that's 0, 2. And it's on the y-axis. That is your y-intercept. Actually, let's label that down here. That's your y-intercept. Okay, so I found a point where x was 0. Let's find a point where I let y equal 0. So this time, I'm going to replace the y in my equation. So I'm going to write minus 8x plus 12. I'm going to put my parentheses. I'm going to throw out the y. And what am I going to put in there? 0. So this is going to give me the x-intercept. So I have negative 8x plus 0 equals 24. Well, adding 0 doesn't do anything, so I'm just going to ignore that. Now, to get the x by itself, divide both sides by negative 8. Undo multiplication with division. Negative 8 divided by negative 8 is 1x, or just x, equals, watch your negatives, negative 3. So this coordinate point is x equals negative 3 and y equals 0. That is your x-intercept. You have an x value, and the y value is 0. So let's plot that point. Start at the origin, go negative 3 to the left, and don't climb at all. That point is right on the x-axis. And now, draw a line, put arrows at the end, and let's label. That is my x-intercept. It is where my line has an intersection with the x-axis. And this point is my y-intercept. It is where my line, right here, has an intersection with the y-axis. So on your notes, make sure you label both of those points, x-intercept and y-intercept. So those are the two methods when you have standard form for graphing the line. Some of you might prefer to put it in slope-intercept form. Some of you might prefer to find the x and y intercept. All right, let's look at the next example. So this one says use method 2. So method 2 is when we find the x and y intercept. So it says use method 2 to find the x and y intercepts of the linear equation. So we're actually not graphing this one, we're just finding the x and y intercept. Okay, let's divide this in half, and I'm going to start with letting x equal 0. So that means I'm going to replace the x in this equation with the 0. So again, I'm going to copy the equation, except where the x is. I'm going to throw out the x, and I'm going to put in a 0. And then I'm going to say, hey, 5 times 0 is just 0. So I'm just going to say, well, this is really just negative 2y equals negative 30. Divide both sides by negative 2. Negative 2 divided by negative 2 is 1. So I have 1y equals, when you divide two negatives, you get a positive. So this is 15. So this is the coordinate point 0, 15. That is your y-intercept. You have a y value when the x is 0. Okay, I already let x equal 0. Now let's let y equal 0. So in this equation, I'm going to copy the equation, but when I get to the y, I'm going to throw it out and replace it with a 0. I'm saying let y equal 0. The reason I can do this is because if I'm finding the x and y intercept, I know the other part of the coordinate point will always be 0. So this is just going to be 5x minus 0 equals negative 30. And again, I can just ignore that 0 and say 5x equals negative 30. Divide both sides by 5. And I get x equals negative 6. So this is the coordinate point, negative 6, 0, which is the x-intercept. I have an x value, but my y is 0. Negative 6, 0. Now, if I wanted to graph this line, I would just graph both those points and draw a line. Okay, one more. Oops. Example 2. Where are you, example 2? Oh, there it is. Okay. So this says use method 1. So method 1 is when I want to put it in slope-intercept form. So I want to get y all by itself on one side of the equal sign. So in chapter 1, we said, oh, that's like y equals stuff. In chapter 3, we want to think of it as getting it in slope-intercept form. Either way, what we want is y all by itself on one side of the equal sign. So we're going to do that, and then it says, then graph the line and find the x and y intercepts. So we're going to get the x and y intercepts off of our graph. So we're going to start this out by doing algebra to get that y alone. So I want to jump that 8x over the equal sign first. So the opposite of 8x is negative 8x. So that's gone. That negative is still there. Be careful. This negative is still there. And over here, again, write that term with the x first. Because when we are in slope-intercept form, we like the slope to come first, then the x, then the y-intercept. But we're not done yet. Now, to get the y alone, we have to divide all three parts of the equation by negative 4. Negative 4 divided by negative 4 is 1y. Negative 8 divided by negative 4, that's going to be a positive, and that goes in there evenly, so that's 2x. Positive 16 divided by negative 4 is negative 4. All right, so now it's in slope-intercept form. This is my y-intercept. So the first point I'm going to graph is 0, negative 4. Hey, that's the y-intercept. So I already know my y-intercept. It's 0, negative 4. My slope is 2. If you're missing a run, add a 1. So my slope is 2 over 1. So I'm going to rise 2 and run 1. Now when we graph it, we should then be able to find our x-intercept. So let's start by graphing our y-intercept. Remember, first point always goes on the y-axis. In this example, it's at -4. And now from that point, I want to rise 2, 1, 1, 2, run 1, and put another point. Keep going because we need to find the x-intercept. So rise 2, run 1, put another point. Rise 2, run 1, put another point. Now very neatly attach your points, put arrows at the end. Okay, that right there is my x-intercept. And it is the point 2, 0. Remember, x and y intercepts always have a 0. This one is 0, -4. That is your y-intercept. So please label those points in your notes. Our y-intercept, we already said, was 0, -4. And our x-intercept is 2, 0. Okay, I would like you to try example 3 by yourself. So I'm going to say example 3 in your notes is a your turn. Example 3 says use either method. So you can decide. You can decide whether you want to find the x and y intercept or whether you want to put it in slope intercept form. That's the end of the video.